Good afternoon. Today we are going to study analysis of truss. Now when we will talk analysis, so we have to find forces in all members. Forces in all members. And when we are going to be with this, so this analysis of truss, this is related with your indeterminate truss. And we have in this 5 type, we have seen externally indeterminate truss. Then we have internally indeterminate. Then we have truss with lack of fit. Then truss with temperature change. And then fifth we have sinking. Sinking of support. So we have these 5 types which we have in indeterminate truss. Now we will have steps we have already seen. Determine the external and internal static indeterminacy, identify the type of truss, remove reaction or members and make the truss determinate, calculate DRL value, and we have seen now whatever problem we are going to solve for that one, we require DRL is equal to summation PKL upon AE. Then remove external loads and apply unit value for reaction. Now we have externally indeterminate problem and or this we need not require in redundant reaction, I will say. Then we have sixth, calculate the flexibility matrix by applying above step. So we know we have F is equal to summation K square L upon AE. Calculate dr value and then we have to use this formula, and using above formula we have to calculate forces in all members. So these steps we have to use. Now we will go with the problem in class. We have started with this problem, that is 60 kilonewton and 40 kilonewton load are acting. So now we will go step 1. So static indeterminacy. Now in this, first we will find DSE, which will be equal to R minus equilibrium equation. So we have 4 minus 3 and that is equal to 1. And DSI we have M minus 2J minus 3 and that is equal to M we have 5 minus 2 into 4 minus 3 and that is 0. So we have truss is externally indeterminate. Externally indeterminate to degree 1. Now we have this 4 reactions we have. We have here 2 reactions. We have 1 reaction over here. We have 1 reaction over here. Now we can consider any of the reaction as redundant. So we are going to consider reaction C as redundant. Step 2. Consider reaction RC as redundant. Reaction RC as redundant. Then we have step 3. We have to find P forces. While finding P forces, remove redundant reaction. Remove a redundant reaction. And then if we will remove the redundant reaction, then we are going to get truss in this way. So we have one reaction here, we have one reaction here, another reaction we have here, we have two forces over here. So this is 60 kilonewton, we have this as 40 kilonewton. So we are in this fashion. Now as we have C joint only two members, so we have these both members are 0. Now we have 60 summation fx 0, so we will get this as 60 kilonewton. This as 60 kilonewton. Now we will consider this joint, so we have this as A joint, B joint, then we have C, and then we have D. Now we will consider joint B. So we have this as 40 kilonewton, and then we have 60 kilonewton. So we have these two members, so this is 0. So now we will assume this as tensile. So we have FBA, we have this as FBD. Now if we will calculate the angle, then we have this angle with horizontal 53.13. So now we will apply summation fx equal to 0, and we will get minus FBA cos 53.13 plus 60, and that is equal to 0. And if we will solve this, we will get FBA, that is equal to 60 divided by cos 53.13. And we have this value, that is 100 kilonewtons. So we have plus value, means assume direction we have correct. Now we will apply summation Fy equal to 0. And then we will get this as Fy 0. So minus 40, then minus FBA sine 53.13 plus FBD, sorry, minus FBD, and that is equal to 0. And solving this, we will get FBD is equal to minus 120 kilonewton. Now as this is plus, so we have tensile. This is minus, so we have this as compressive. So now if we will put these values in the diagram, then we are going to get these values. So we have BA, which is tensile 100 kilonewton, and BD, we have compression 120 kilonewton. And then we have to consider that is joint A, and then we have to solve for the member. Now you can see, now if I will come to joint D, then we have these two are collinear, and we have these two are collinear. Now in these two, if it is 0, we should have this value as 0. And then we have force in members, that also we have to show, which are 0 members. So we have this also 0, 0, 0. So by taking C as redundant, we are going to get 3 members 0, and therefore we have considered or C as redundant. So now we have this as P values. Now we will go with values that is K, and how we will get that K values? So we have to remove all external loads and we have to apply unit load that is at redundant reaction, and therefore I will draw this diagram. So now again we have this truss, then we have this. Now reaction we are going to be 1, then we have this reaction, here we have reaction 2. Now if we will start with this, we have this as 53.13, and then if we will start this, so A, B, C, D. Now if we will apply at C, if we will consider, and then at C we are going to be this value as 1. So this is FCB and this is FCD. So we will apply first summation Fy0 and we will get F plus FCB sine 53.13 plus 1 equal to 0, and we will get FCB that is equal to minus 1.25. Then we will go to summation Fx0, and then we will have this value that is FCB cos 53.13. This is minus. Then we have minus FCD equal to 0. And we will get FCD that is equal to 1.25 sine 53.13. And then that value we have FCB cos 53.13 minus FCD and 1.25 cos 53.13, we will have 0.75, and we have plus, so this is tensile, this is minus, so we have 1.25 compression. And then we have to show these values in truss, that is most important one. So we have this as compression 1.25, and then we have this as tension 0.75. Now we will get, if we will consider joint D, then we should have this as the same 0.75. Now you can see we have this as 1.25 angle making 53.13. This is also same. So we are going to get force in this also same value. You can calculate it 1.25. Then only horizontal component will be balanced. Now we have in both these one component which will be vertically upward. So we will get force in this. It should be 2, which should be downward. Means you can try to solve it. You can consider the joint, and then we have this value as 1.25, and then you have this force in member FBA, and if we will apply summation Fx equal to 0, then we have minus FBA cos 53.13 minus 1.25 cos 53.13, and that is equal to 0. We will get FBA minus 1.25, and minus indicate we have again it has compression. And then both component of this end is 1 upward, so automatically we have in this that is 1 downward. So likewise we have to find out K forces. Now we have to show these all forces in the table, and then we have to find the value of redundant, and then we will get PF is equal to P plus QK. Now we will go member length area PK, PKL, K square L. PF is equal to P plus K into R. Now we will go one by one member in this and we will write the values of all. So we have first member, I will say we have that is AB. So we have AB. AB we have length that is 5 meters. So we are taking in meters. Area we have common A. Then P we have 100. So this value is in kilonewton. K we have minus 1.25. And from this we will get PKL that is minus 625. If we will calculate K square L, we will get 7.85. Then we have second that is BD. I have taken first all which have P forces. So we have BD for area again A. P we have in this minus 120. K we have in this plus 2. Then we will get this value minus 960. And then K square L we have 60. Then we will go third member which is AD. AD we have 3 meters, A we have same, P we have 0, K we have 0.75, PKL is 0 and K square L we will get 1.69. 1.69. Then we have next that is DC member. So we have member DC. We have again 3, we have area A, we have P0, K we have 0.75, PKL we have 0, K square L we have 1.69, and we have last member which is BC, and this member we have 5 meters, area we have A, P we have 0, K we have in this minus 1.25, K square L we have same which we have here, that is 7 point, here we have 3 AD, for we have 1.69 AD DC, and BC we have 7.81. So this is 7.81 which is of AB. Same we have here 7.89 because we have all data same. And from this we are going to get this value, that is summation PKL. If we will see, then we are going to get this summation PKL. That total value we have 1585. So this value we have 1585, which is summation PKL upon A. E we have constant, and then if we will calculate this summation K square L upon AE, then we are going to get this value, that is equal to 35. And then we are going to use dr is equal to drl plus f into r, and if we will put it, then we have this value as 1585. Now this is minus, so minus 1585 plus f we have 35 into r, and from this we will get value of r, that is equal to, so we have value of r, that is 45.29 kilonewtons. Now by using PF is equal to P plus KR, I will show for one member. So we have for member AB, this P we have 100, then K we have minus 1.25 plus 45.29, and we will get this value, that is in AB 43.44. Then you go for BD. BD we have minus 120 plus 2 into 42, 45.29, and then we will get this value that is equal to minus 29.42. So AB we have plus, so tensile. BD we have minus, so we have 29.42 compression. Then AD, if we will calculate, then we have 33.97. Now this we have directly value that is of AD. So we have tensile both. So directly AD how we will get, so 0.75 into 45.29, and we have this as tensile. Then this also we have 33.97, we have tensile, and last we have BC. BC we have minus 1.25 into 45.29, and it comes minus 56.61. So we have 56.61 as minus, so compression. So likewise we will get these values, and this is all about our truss. And actually we have to show it in the diagram. So AB we have tensile, so we have this as tensile 43.44. BD we have compression 29.42. This diagram is most important. Then we have AD, so we have tensile 33.97. Then DC also we have tensile 33.97, and then we have compression 56.61. So this diagram shows your all forces. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.